3.4 Piecewise Defined Functions and Library of Functions. So the last sheet of the notes, I'm just going to go to it now and talk about it a little bit. It's the library of functions. So it's kind of like the most important graphs that you should know or know a little bit about of. Um, I mean, do you need to memorize this for this class? Absolutely not. Do not focus on memorizing any of this for the class. For this class, but if you're going on to like, if you're going to go to like Calculus 1, Calculus 2, Calculus 3, if you know that's your path, it's not going to hurt to know this information, but you will start to memorize it over time. So this is just an introduction to it. Read it. If you should go through it, read it, because you'd be like, oh, okay. So instead of actually doing it by math, I just know this, and I'll break that down a little bit. So if we do the square root of x, the domain and range are a set of all non-negative real numbers. So we could find that, right? If we're given an equation, we can totally find it, or we can just know that. The x-intercept is always 0, and the y-intercept is 0. So we could always, again, we could find that by how we usually find intercepts, but it doesn't hurt to know it sometimes. It's not even, it's not odd, okay, but we could also find that. We don't need to memorize it. We know that. We can figure out if it's increasing, and we can figure out the absolute minimum. So you see how like 1 through 5, you can figure it all out, because we've learned that through the semester already. We've learned how to find all 1 through 5. We did that already. So you don't need to memorize it, because we know how to find it. It's just a helpful tool to know it if you're going to calculus and stuff like that. Okay. Hopefully that all makes sense. Now let's talk about piecewise defined functions. Yeah, we're starting off with an application. What? Don't we always end with one? Nope, we're starting with one here, because I want to show you right away what the heck is a piecewise defined function and why are they so important. One word. Why are they so important? One word. Money. That is why. It's bills, mortgage payments, 401ks, which are retirement plans, stocks. I can keep going. They're all governed by piecewise defined functions. Seriously, they are. Your phone bill is governed by piecewise defined functions, and that's why we're going to use this example. So, example 1, a telephone company offers a monthly phone plan for $29.99. It includes 250 anytime minutes plus 30 cents per minute for additional minutes. The following function is used to compute the monthly cost for a subscriber, where x is the number of anytime minutes used. So a piecewise defined function is multiple functions create one. So it's just like pieces make one puzzle. The left side is the function. The left side represents the function. The right side, this side right here, that is actually the domain. Anytime you see inequalities like that, it's always your domain. So we're given the function, and we're given the domain, because the domain lets me know what x can and cannot be. So we actually have two functions. We have c of x equals 29.99 if x is in between 0 and 250 inclusive. And then we have our second function of c of x, sorry, wrong color. C of x equals 0.30x minus 45.01 if x is greater than 250. So let me break down each of those pieces with the problem. So they offer a monthly plan for $29.99. It includes 250 anytime minutes. So that's 0 to 250. So you see how we got $29.99 and 0 to 250? It's cool, right? Really pay attention to what I just said. You are going to need it, okay, for the homework and for the test. So see how it says the base plan is $29.99? Only if it only includes 250 anytime minutes, and then anytime minutes, that represents x, because it tells me x represents the anytime minutes. So that means x for anytime minutes needs to be between 0 and 250, and it costs you $29.99 for that plan. Then if we keep going through the word problem, plus 30 cents per minute. So if I go over 250, they're going to charge me $30, 30 cents extra. Why 45.01? 45.01 is when x is 250, your cost is 45.01. So that's why. That's the start. Remember, that's the start. Ooh, apparently I can't spell, gosh. That's the start, or the y-intercept, or how much it costs for your anytime minutes. Okay, you're not going to have to go that far. You're just going to have to get the $29.99, 0 to 250, something like that. You'll see on the review. It's not going to be a surprise. You'll see it on the review. Alrighty, so part A. Compute the monthly cost of the cellular phone for the use of 130 minutes. So part A, we're given x is 130 minutes because I know x represents minutes. So what I'm going to do is I'm going to use the domain and see where it fits. So if I put 130 here, is 130 greater than 250? No. If I put 130 in the middle on top, is 130 between 0 and 250? Yes, it is. Since it works for this domain, I'm going to plug it in to the equation directly left of it. So when x is 130, it tells me cost is $29.99. I have nothing to plug it in. That's it. That's my answer. So our answer is the cost to speak 100 or to use. We're not saying we're speaking. To use 130 minutes is $29.99. Because that's in part of our base plan. We didn't go over, so we're good. We didn't go over. They're not going to charge us more. All right. What I want you to do is go ahead and try B. So pause it and try B. Work through the steps that we just did. If you're like, I don't remember the steps, rewind, watch it again, and then I want you to try this. Okay. Okay. I hope you tried it. Let's get to our problem. I hope you know I just get the biggest kick out of asking you to pause it and then having you come back, because like I've said, it just reminds me of like Dora and stuff like that, like kid shows. It's just funny. All right. So, part B. We're given 315 15 minutes. So we want to know how much is it going to cost if we have 315 minutes. Like if we use the phone for 315 minutes. Back in the day before unlimited. You know, like back when I first got my cell phone, I was in college, and I had to pay $20 more to get unlimited texting. So, like, I got 200 free minutes, and then I had to pay an extra $20 to get unlimited texting. If not, it was like 5 cents a text. So, like, my dad was like, oh no, you're paying me to get unlimited texting. So I had to do that. I had to give him $20 a month to get unlimited texting. Anyways, some of you get what I'm talking about. All right. So 315 minutes, we're going to do the same thing. We're going to use the domain and see where it works. So if I put it in right here, 0 and 250, it's not, 315 is not between 0 and 250, so it does not work there. Let's see about the bottom one. 315 is greater than 250. That does work. So since it does work, I'm going to plug it into the equation directly left of it. So the equation directly left of it is cost equals 0.30x minus 45.01. And what we're going to do is plug in x for 315. So we have cost equals 0.30x, which is 315. minus 45.01. So just plug that into your calculator exactly the way it looks, or piece by piece, it's up to you. So we get cost is 49.49. So that means it costs 49.49 to use 315 minutes. That's a lot of money, right? It's almost doubling. So we have to write it as a sentence. So it costs 49.49 to use 315 minutes. All right. So now you kind of have an introduction to what piecewise defined functions are. It's just like multiple things that make one bill. So that's how I like to think about it. It's like sometimes, it depends on how much you use or how much you save, and that depends on how much money you're going to get back or how much money you're going to pay. So before I continue on, I want to talk to you about your water bills and your electric bills. If you have like elderly grandparents or elderly parents, you should actually go over their water bill, read through it, and they're going to give you a function that looks something like this. They're going to give you something that looks like the function we just used. Plug in how many minutes or how many kilowatts an hour or how much gallons they used, and make sure they're not being overcharged. It is a real thing that they see the account, they see how someone is old, and a lot of elderly people, they're like, they're trustworthy. They're not gonna take the time to plug in numbers, and they're gonna hope that the electric company isn't screwing them over. It's a real thing that happens. So like, just be a good grandchild if you do have grandparents, and once in a while look over their bills, maybe just a couple times a year. Make sure they're not getting screwed over. It does happen way more often than you think, and it's super sad that they're totally allowed to do this. Okay, I digress. Example 2. Let's start graphing. Oh yeah, we can graph these things. We can graph anything. Pretty much anything we can graph. And you're going to see throughout the rest of the semester, and I know we've already graphed a lot, we're going to graph even more in Chapter 5. You're going to see some pretty cool things in Chapter 5. I'm pretty psyched about that. It's my favorite chapter for the graphing. Alright, so we're going to graph, find intercepts, domain, and range. So the first thing we're going to do is graph. But before we do that, let's pull out each equation. So we have 3 equations here. Remember, f of x just means y. So we have y equals negative 4 if x is less than or equal to negative 2. Then we have y equals x minus 2 if negative 2 is less than x and x is less than 2. So x has to be between negative 2 and positive 2. And then our last one, we have y equals negative 2x plus 4 when x is greater than or equal to 2. Alright, I want to see if you remember what we do if we don't know how to graph something, because we don't know how to graph this right now. Even if you do, I'm pretending that you don't, because if you've taken pre-calc, you might have seen this. I don't know. But right now, no one knows how to graph this. So anytime you don't know how to graph something, we bust out a chart, a T-chart. That's why I teach T-charts, because you can always use it, and that's exactly how we graph these. It's the easiest way to graph these. There are different methods, but I don't like to teach them because I feel like sometimes if I give you too many methods, when things are a little harder, we start to get them confused, and I do the same exact thing. I get things confused when things get a little more hard. So I'm teaching one method here. If you want to see other methods, just Google it on YouTube. But for this class, I'm going to teach the easiest method and the most applied method. It's the method that most people use. And then we continue using T-charts as we go through math and calculus and stuff like that. Okay, so we're going to start at the bottom and work our way up. So let's start off with the orange one. So we draw our T-chart. Yep, we draw our T-chart. So remember, that little thing, that's the domain. So isn't the domain what x can and cannot be? So it's what x can be. So what this is saying, x can be negative 2 because of the sign underneath. So we're going to pick 2. We are going to pick that 2. You always, always, always pick the number they give you no matter what. So they give us a 2, I'm going to use it. So 2. Now, you usually want 2 to 3 points, so I want another number greater than 2. 3. It's a line. You can keep going, so let's do one more point just for fun. What's another number greater than 2? 4. Awesome. So let's go ahead and plug them in. We have y equals negative 2x plus 4, and the x we're plugging in is 2. So we simplify, that's negative 4 plus 4, and we get 0. So 2, 0. We do the same thing with 3. So y equals negative 2 times 3 plus 4. We simplify to get negative 6 plus 4, which is negative 2. Alright, we're going to do the same thing with 4. Since this is a line, you can probably guess it. It's going to be negative 4, because lines, the slope is constant. So we have negative 2 times x plus 4, and the x we're plugging in is positive 4. Hate when that happens. Alright, we simplify, so we get negative 8 plus 4, which is negative 4. Alright, we got to be careful here. I'll tell you why we have to be careful. Let's see if you remember this. So if there's no line underneath, it's an open circle, and we use parentheses. If there is a line underneath, we use a closed circle, and we use brackets. So we're actually going to talk about using open circle, closed circles on a graph. So we need to go back to our x's, and 2. If I put a 2 here, is 2 greater than or equal to 2? Yes, it is. Since that is the fact, I put a closed circle. Any other number that is not listed, you put a closed circle. But if you can't remember that, just plug it into the domain. So let's plug in 3. Is 3 greater than or equal to 2? Yes, it is. So that's closed circle. And then is 4 greater than or equal to 2? Yes, it is. So closed circle. If it's a true statement, it is a closed circle. If it is not true statement, it is open circle. You will see that very shortly. You'll see that with the purple one or pink one, however you see it. Okay. All right. Moving on. Like, seriously, don't graph it. Let's just move on. We'll graph it later. Let's just find points. That's our goal, is just to find as many points as we possibly can. So moving on to the next one. First thing we do is draw our t-chart. Alrighty, so let's draw our t-chart, and we're given 2 numbers. And remember, that's the domain. Since that is the domain, it's what x can be. So if we're given a number, you use it. And we're going to use those 2 numbers, negative 2 and 2. Wrong color. Negative 2 and 2. If you're given 2 numbers, you don't need a third. You don't, but let's just do a third for practice. And so pick a number between negative 2 and 2. I'm going to pick 0. Why? Because I can, and you should always. If you can pick 0, always pick it. You'll see why in a minute. I promise you it pays off. So if you can pick a 0, if it works in the domain, always, always, always pick that 0, okay? So let's plug it in. We have y equals x minus 2, so the x we're plugging in is negative 2. So negative 2 minus 2, we get negative 4. All right. Then we plug in 2, so we have y equals 2 minus 2. So we get y equals 0. Let's plug in 0. We have y equals 0 minus 2, which is minus 2. All right, let's look at our domain and figure out open circle, closed circle. So there's another way we can do this. At negative 2, okay, come on, buddy. There we go. At negative 2, let's look at the sign next to it. There is no line underneath. Since there is no line underneath, open circle. With positive 2, the sign next to it has no line underneath. Since that is the case, it's open circle. Now we're going to plug in 0. 0 is in between -2 and 2. So since that is a true statement, closed circle. This is a compound inequality. Compound inequalities have a start and a stop. I'm going to write that, don't worry. Compound inequalities have a start and a stop. Single inequalities go on forever. So the purple one is compound, the orange one is single, because compound means double, single means one. Go back to 1.5, 1.6 to review that if you need to. All right, we have all our points, we have all our circles that we need to fill it in with. Last one. All right, so let's draw our t-chart. No matter what it looks like, we always draw a t-chart. Now we're going to pick numbers that are less than -2. We also pick that one because it's given, so we always pick it -2. Another number less than -2 is -3. Another number less than -3 is -4. So now we have our x's. We're going to plug it in to the equation. How? There's no x. Okay, so it's saying y equals -4 is if x is less than or equal to -2. So you know what that's telling me? Whatever x is, y is -4. Cool, right? So now we have to look at our points. So with -2, there is a line underneath. Since there is a line underneath, we do close circle. Now let's do the same thing. So -3, we plug it in here. -3 is less than or equal to -2, so close circle. Do it again with -4. So -4 is less than or equal to -2, so closed circle. Now we have all of our points. Let's just plot all of our points and not connect dots yet. Just plot points. So I'm going to plot my orange ones first. So I have 2, 0. That's right there. I have 3, -2. That's right there. And 4, -4. Okay, so we plotted our points for our first one. Now, since this is a single inequality, that's a single inequality, and the arrow is pointing to the right, it's going to go on forever. And I'm going to point the arrow to going towards the right. And it is, like, it's going down and right. So what I mean by that, I wouldn't do this, because that's the arrow going left. That means less than. Left is less than. So since the arrow is pointing right, the inequality is pointing to the right, I'm going to connect the dots going towards the right as much as I can. Now I'm going to plot my purple one. So my purple one is a compound inequality. Since it's compound, it has a start and a stop. So I'm going to plot my points at -2, -4, it's open circle. At 2, 0, it's open circle. And at 0, -2, it's closed circle. I'm going to connect the dots, and it doesn't go on forever because it is a compound inequality. So no arrows, it just start and stop. This point right here, you see how an open circle went over a closed? It's still closed. You know the little game you give kids where you put like the sphere, and you put the pyramid, and then you put the rectangular prism, and you put them in like the little shapes, the little blocks, and you put them in the shapes. So you know how you put the sphere in the hole, it covers it? Same principle here. When you put an open circle on a closed, it's still covered, and when you put a closed on an open, it's covered, okay? All right, now we plot our green one. So we have our points -2, -4, closed circle. So now that's a closed circle now. Then we have closed circle -3, -4, closed circle -4, -4. And since this is a single inequality, that is a single inequality. Since it is single, it goes on forever, and the arrow points to the left. So I'm going to connect the dots going towards the left. And that is our graph. Cool, right? I don't know. I love this stuff. All right, so let's keep going through the example. Let's find the intercepts. So to find the intercepts, we look at the graph. Because remember, intercepts are where they cross or touch. So I'll highlight them. We have, let me get a different color. We have one right here and another one right here. So let's see if we can find them within our points, the points that we have. So remember, an intercept is when something is 0. You have either x or y 0. So we have a 0 here, a 0 here, and a 0 here. So we have 3, well technically 2 because some of them match. So we have an x-intercept at 2, and then we have a y-intercept at -2. And remember, because that point is 2, 0, and this point is 0, -2. Later through the examples, you're going to find another way to find intercepts. All right, domain. So remember, domain is what x can and cannot be. So for the domain, there's a trick. There's a trick for the domain. So looking at our domain, remember this part is the domain, so we're only looking here. So you only ever look at the first one and the last one. So like find the domain of each of those. So the first one, it's going to the left forever. So the left is -infinity. The last one is going to the right forever. So the right is +infinity. So that's our domain. We're going to practice that a lot more, but that's our domain. Always look at the first and the last. Now let's find our range. To find the range, we can only look at the graph. That's the only ever way that we can do that. There's no other way. So to find the range, I'll do it right here in blue. So just like parabolas, let's look at the arrows. We have an arrow going left and an arrow going down. So it's going down. If it's down, you're frowning, right? You're -infinity. And then you go to the biggest y, because this is it's like a frowny face, right? It's going down. It's a weird frowny face, but it's still going down. So then you go to the highest y, which is 0. And that's the point right there. Since it's a closed circle, it's a bracket. All right, there's something I want to ask that I did not put here. Is f continuous on its domain? That's what I want to ask. So what does that mean? No gaps, no gaps, no holes, or any other words that mean gaps or holes. So a gap means like literally there's a gap in the graph, and the hole means open circle. There are no open circles here because everything got filled in. And everything is connected on this graph. So since that is the case, the answer is yes. X is continuous on its domain. Don't look at the actual domain in red. That has nothing to do with that question. Always look at the graph. All right, let's practice this some more. We're going to graph it, find the domain, locate intercepts. Based on the graph, find the range, and then we're going to see if it's continuous. Alright, there's a couple things that we can do. It's like we can graph it first, we can find domain first, we can find intercepts first. It's up to you what you want to do. I'm going to find domain and range first, or excuse me, just domain. We can't find range unless it's from a graph. So let's find domain. To find domain, we only look at the first and the last. So the first one is going to the left, so that's negative infinity. And the right one, it's a single inequality, and it's going to the right. That means positive infinity, so that is our domain. It's the domain of the whole piecewise-defined function as one. So it's like you have the multiple pieces of the puzzle, but when you put it together and complete the puzzle, your domain is negative infinity to positive infinity. All right. Now let's go ahead and graph it. I just wanted to find the domain first. So we have three functions. We have y equals negative 3x if x is less than 1. We have y equals 0 if x equals negative 1. And we have y equals 2x squared plus 1 when x is greater than negative 1. Alright, same as before, we do our t-chart. So I'm going to start at the green one. So we have our x, we have our y. You always pick the number you're given. So we're given 1. Now another number less than 1, 0. Let's do another number, negative 1. So we're going to plug them in. We have y equals negative 3 times 1, which is negative 3. Alright, we just keep going. So we have y equals negative 3 times 0, which is 0. Then we have y equals negative 3 times negative 1, and that equals positive 3. So now we have to do open circle, closed circle. So with the 1, the sign does not have a line underneath, so it's open circle. Now for the rest, since it's not the number given, it's always going to be closed. But let's say you forget that, let's just plug it in. So here, 0 is less than 1, so that's true, so closed circle. And then negative 1. Negative 1 is less than 1, so since that is a true statement, closed circle. Now we keep it going to our purple or pink one, however you see it. It looks like Barney purple. So y equals 0 if x equals negative 1. I have no equation there. I'm just given x and I'm given y. I'm given y, I'm given x. I'm given a point. It's literally just a random point. That's it. Alright, last but not least, we have a quadratic. How do I know? Because it's squared. If you have a quadratic, 3 points, at least 3 points for a quadratic, because you need to get the shape, because a quadratic does like the little swoosh. It goes down then up or up then down. So you need to get the shape, so you want at least 3 points. Alright, the first number we're going to pick is negative 1. Why? Because they gave it. Now we want another number greater than negative 1, 0. Another number greater than negative 1, positive 1. So since the number we picked is negative 1 and the sign next to it does not have a line underneath, it is open circle. Now for the rest, since they are not given numbers, they're always closed, but let's say you forget that, so we're going to plug it in. We have 0 is greater than negative 1. That's true, so closed. 1 is greater than negative 1. Since that's true, it's closed. Let's plug them in. So we have 2 times negative 1 squared plus 1. So that's 2 times 1 plus 1, which is 3. We plug in 0 this time. So 2 times 0 squared plus 1 is just 1. And since this is a quadratic, opposite x's always have the same y, but if you don't remember that, let's plug it in. So we have y equals 2 times 1 squared plus 1. So we have 2 times 1 plus 1, and that's how we get positive 3. Alright, now that we have all of our points, let's go ahead and start graphing. So plot that random point at negative 1, 0. Done there. We're done with it. Okay, let's plot our green one. So our green one is a single inequality, so we know it goes on forever to the left because that's the way the arrow is pointing, so keep that in mind. So our point, we have 1, -3, open circle, 1, -3, open circle, 0, 0, closed circle, -1, +3, closed circle, and the arrow is pointing to the left, so we connect the dots, kind of pointing, going to the left. All right, next we do our quadratic. So we have open circle, -1, 3. Then we have closed circle, 0, 1. Closed circle, 1, 3. And the arrow is pointing to the right. This is a single inequality, so we're going to connect it like a parabola does. It makes that U shape, right? And since we read left to right, that's why it doesn't go up like this, because if it went up like that, the arrow is pointing to the left. That's not right. The arrow has to go up and to the right because the arrow is pointing to the right. And that is our graph. All right, let's locate any intercepts. So any intercepts, remember that's where it crosses or touches. So we always look at the graph and see if we have those points, and we do. We have 0, 0, and then we have that point right there at 0, 1. So we have an x-intercept at 0, then we have a y-intercept at 0 and +1. Because remember, if it's 0, 0, that means it's both. It shares. Now let's find the range. So part C, the range. So this is pointing up. It's a smiley face because the arrows are going up. So when you're up, you're positive. And then it starts here. It starts right here and it goes up. So that y value is -3. And since it's open, it's parentheses. And that's our range. Is f continuous on its domain? No. There's a hole. There are gaps, but there's a hole. Done. That tells me everything. So no, it is not. No, and we're going to say why. It's because there's a hole, which is open circle. Okay. All right. It's telling us to find a bunch of stuff and then graph it. So you know how before the previous examples we were graphing and then finding out the stuff about it? We're going to do it the opposite way now. So we're going to find out stuff about this and then we're going to graph it. Part A, I'm going to do it up here just because I need the space. So part A wants us to find f of -2. It wants us to find f of 1. And it also wants us to find f of 2. So these values they give us, those are x's. So what this is saying is I have x at -2, I have x at +2, and I have x at 1. So because that's what it's saying, those are my x's. And remember that if part, the if part right here, remember that's our domain. And domain states what x can and cannot be. So if we're given an x, let's see if the domain even supports it. So if we have x at -2, if I go all the way to the bottom right here, is -2 greater than 1? No. Is -2 equal to 1? No. Is -2 in between -3 and 1? Yes, it is. So since -2 is in between this function domain, we're going to plug -2 into that function. So we have y equals -2x, which is -2, plus 1. So we have 4 plus 1, which is 5. So f of -2 equals 5. All right, we're going to move on to our next one. So our next one, we have x equals 2. So let's see where that fits. I went to the right. That's all I did. I'm going to the right. So for 2, if I put 2 right here, see how it doesn't work? 2 just doesn't work there. Because if I put 2 here, 2 is not greater than 1. Or excuse me, 2 is not less than 1 right here. 2 does not equal 1, but 2 is greater than 1. Since 2 is greater than 1, we're going to plug it into this one. So we have y equals x squared, which is 2 squared. So we get y equals 4. That means our function notation is f of 2 equals 4. And now we move on to our middle one. So our middle one states that they are doing x at 1. So if x is 1, 1 is not less than 1, 1 is not greater than 1, but 1 does equal 1. So when we do this, we have y equals 2 if x equals 1. There's no equation there, so our answer is f of 1 equals 2. That's a special point 1, remember that? Alrighty, let's determine the domain without graphing this. Alright, so domain. When we look at our domain of the entire piecewise function, we always want to look at the first domain and the last domain. So the first domain, since it's compound, remember compound has a start and a stop. So it starts at bracket -3, and then the last, so that's where the whole function starts, and then the last one, x is greater than 1, that means it goes greater than is infinity. Alright, part C, intercepts. Alright, so intercepts, we always have two types. We're always going to start with y first. Y-intercept is usually the easiest thing to find in almost every equation. The y-intercept is one of the easiest things to find. So for the y-intercept, we make x equals 0. So that's what x has to be. So let's just see if that fits the domain. So if I go to the bottom one, 0 is not greater than 1. Middle one, 0 does not equal 1. Top one, 0 is in between -3 and 1. So since 0 is in between -3 and 1, it fits there. I know that the top one has a y-intercept. So I'm going to replace 0 as x. Since that domain supports 0, I plug it into this equation. We get y equals 1. So our intercept, our y-intercept is 0, 1. That's the only equation in the domain that actually supports x being 0. For the x-intercept, there's no trick, we just have to test it. So for each equation, we're going to make y equals 0 for the equation. You notice the middle one, the blue one, that's not an equation, so we don't care about that at all. So every equation, we're going to test it. So we have 0 equals -2x plus 1. We solve for x, so I'm going to add 2x. So we have 2x equals 1, divide by 2. So we get x is 1/2. Does the domain support 1/2 of x? So if we go back to the top domain, if we go back to the top for 1/2, 1/2, if I put it here, it works. 1/2 is in between -3 and 1. So this is an x-intercept because it works for the domain. Now we have to do the same thing with the bottom one. So the bottom one, we have y equals x squared, so we're going to replace that with 0 equals x squared. And then we get 0 equals x. But if we plug that into the domain, 0 is not greater than 1. So the domain doesn't support it. So the domain of y equals x squared doesn't support x equals 0, so we leave that alone. It's nothing to us. We just tried it. It didn't work. Oh well, that happens, right? Alright, now we need to graph this. So we're going to graph it how we always graph this in class. We're going to bust out our fancy t-charts. I don't care that I have more points. I don't care about any of this. I want to use t-charts. So part D, I'll do over here. So remember, we break them up individually. So we have our first one, Our first one is y equals negative 2x plus 1 if x is in between negative 3 and 1. I put that line in the wrong place. There we go. And then we have our next one. So our next one, the middle one, that's just a point, and we technically have it right here. It's 1, 2. So that's nothing. We don't have to do anything there. It's just a point. It's not an equation. So our next equation is y equals x squared if x is greater than 1. So we do our little fancy t-charts. And then since the purple one is in compound inequalities, you use both numbers and nothing more. So negative 3, 1. Since negative 3, negative 3, since it's attached to this one right here, it's closed circle. And 1, since it's attached to this symbol, it's open circle. So we plug it into our handy-dandy equation. We have y equals negative 2 times negative 3 plus 1. So 6 plus 1, we get 7. We do the same thing with 1. So we have y equals negative 2 times 1 plus 1. So it's negative 2 plus 1, which is just negative 1. So those are our 2 points for that. All right, now we do the same thing with our green one. So x, y, we're going to pick this one because it's given to us, so 1. And since we have this symbol, it's open circle. And then we need, since this is a quadratic, we need 3 points. So I'm going to pick 2 and 3. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And since 2 is greater than 1, close circle. Since 3 is greater than 1, close circle. Now we have everything we need to graph. So I'm going to plot that random point of 1, 2. So 1, 2. And then we're going to plot the other points. So we're going to plot the purple one. So we have a closed circle at negative 3, positive 7. We have open circle at 1, negative 1. And since this is a compound inequality, that is exactly where it starts and stops. My bad. We also have more points. I totally forgot to bring those up. All the other points we found. Didn't we find this one right here of negative 2, 5? So negative 2, 5. We also have another point at 0, 1 right here. And then we have another point at 1/2, 0, so about right there. And then we connect the dots. The more dots, the better, because you get a better line. Now we graph our green one. So our green one, remember, it's a quadratic, so it's going to like swoop and have a curve. So open circle 1, 1. So open circle 1, 1. Close circle 2, 4. Close circle 3, 9. And then since it's a quadratic, we kind of want to make it like swoop up, and it does go on forever. The green one, since it's a single inequality, it goes on forever. The purple one is compound inequality, so it has a start and a stop. Now, based on the graph, we want to find the range. I'm actually going to do it right here in purple. So range. Since this is going up, the graph points up, we have a range that is going towards infinity, and it starts at this point. Remember that this point is 1, negative 1. So that's the one we take because it's the y values. So negative 1. And since this point is an open circle, we use parentheses. F is not continuous on its domain because we have gaps and we have holes. Example 2. So we have our 3 equations. Let's go ahead and underline them. Alright, so for part A, it's telling us we have f of negative 2, which is just x equals negative 2. We have f of 1, meaning x equals just 1. And then we have f of 2, which just means x equals 2. So let's look in our domain and see where they fit. Alright, so negative 2. Is negative 2 greater than 1? Nope. Does negative 2 equal 1? Nope. Does negative 2 fit in between negative 4 and 1? Yes, it does. So that's what I'm going to plug it into. I'm going to plug it into y equals negative x plus 2, and we're replacing it with negative 2. So we have 2 plus 2, which is 4. So f of negative 2 equals 4. Alright, now we go on to our next one. F of 1. So f of 1, that means x is 1. So 1, that's not less than 1. 1 is not greater than 1, but 1 does equal 1. So we're going to plug it into our middle one. It's saying y equals 2 if x equals 1. So f of 1 equals 2. Remember, that's just a special point. Alright, now we're going to our last one. So our last one says f of 2. So that means x equals 2. So if we plug it into our first domain, 2, that's not less than 1. 2 does not equal 1, but 2 is greater than 1. So we're going to plug it into the bottom one. So we have y equals x minus 4, and the x we're plugging in is 2. So we have y equals negative 2. So f of 2 equals negative 2. Alrighty. So we did all that part A. Great. Now let's find the domain. So the domain, remember, we look at our first one and our last one. So since the first one is a compound, we have a start and a stop. So it starts at bracket negative 4, and then the last one, it goes to infinity. Alright, intercepts. So remember, we always, if you didn't graph it yet, let's start off with y-intercept, and then we can do our x. Because with the y-intercept, we make x equals 0, so we can check that with the domain. So 0, not greater than 1. 0 does not equal 1. 0 is in between negative 4 and 1, so that's the one we're going to plug it into. Since 0 fits in the domain of the top one, we have y equals negative x plus 2, so y equals negative 0 plus 2, which is just 2. So our y-intercept for the green one is 0, 2. Now we do our x-intercepts. So x-intercepts, we have to just test every equation. So let's test our top one. Remember, that's where we make y equals 0. So we have 0 equals negative x plus 2, so x equals 2. Does that fit in the domain? Is 2 right here? So if I put 2 right here, is 2 less than 1? No. So the domain doesn't support x equals 2. So that doesn't count. Now we have to try our next one. So our next one, our last one, which is the orange one. So the orange one I'll put down here. We have y equals x minus 4. So let's replace y with 0. So we have 4 equals x. Now let's check that with the domain. So if I put 4 right here, 4, is that greater than 1? It totally is. So since 4 is greater than 1, we can say that is a intercept. So we have an intercept for the orange one at 4, 0. Alright, now we can graph this. So anytime we need to graph it, you bust out more points. You make that T-chart. So we have our first one. Alright, so since it's a compound, it has a start and a stop, and we're going to pick those numbers. So since negative 4 is with this sign, it's going to be closed circle. And since 1 is with that sign, it's open. So we plug it in. We have y equals negative negative 4 plus 2. So 4 plus 2, we get 6. And then we have y equals negative, so then the x becomes negative 1 plus 2, and we get y equals 1. Now the middle is just a point, so we could care less about it. And remember that point, it's just 1, 2. So let's do the last one. So the last one, we make our handy dandy t-chart. So we have y equals x minus 4 if x is greater than 1. So since it says x is greater than 1, that's the x we're going to pick. And then we need one more point. That's not a quadratic, so we only need 2 points. So I'm going to pick 2. So 1 is not greater than 1, open circle. 2 is greater than 1, so close circle. We plug it in. We have y equals 1 minus 4, which is negative 3. And then y equals 2 minus 4, which is negative 2. Alright, we have a whole bunch of stuff to graph. That's more than enough. Let's plot that random point. So 1, 2. Now our green one. Our green one, we have points at negative 2, 4. We have points at 0, 2. We have points at negative 4, 6. That's closed circle. And we have open circle at 1, 1. Since that's a compound inequality, it has a start and a stop. It does not go on forever. Okay? Since it's compound, it does not go on forever. Now we do our orange one. Our orange one is a single inequality, so it does go on forever. So for our orange one, we have points at 2, negative 2. We have points at 4, 0. We also have points at open circle 1, negative 3. And then closed circle 2, negative. Oh, we already did that. It's there. 2, negative 2. And since this goes to the right and it goes forever, we make it go up and to the right. Alright, so the range, since it's pointing up, I'm going to do the range out of space. I'm going to do it right here. So part E, since it's pointing up, you're positive, and it starts at negative 3, since it's open circle, parentheses.